My name is Hannah Ryder and I'm a third-year PhD student in the Cresswell Group at the University of Bath. My research focuses on using Photoredox Catalysis to functionalise amines without the use of protecting groups. And this is really hard because you have to combat the traditional N-reactivity of an amine. This can be achieved through low temperature. Both flow chemistry and photochemistry are completely essential to the work I do. For amines, they traditionally react at the nitrogen, so to combat this, you have to form an alpha amino radical. So for this, to generate the alpha amino radical, you need photochemistry. However, secondary amines are also very nucleophilic. So to combat the N-reactivity, it is absolutely vital that we have low temperature. Therefore, the use of low temperature flow is absolutely essential in forming the product desired. I regularly go down to minus 25 degrees. However, others in the group go as low as minus 60. To stop the ice formation, we need a strong flow of nitrogen. Luckily, the reactors that we use, such as the PhotoSyn here, have a nitrogen inlet, so we can blow nitrogen through, dry nitrogen, and that stops the coil icing up. I started off using this equipment in flow quite early on, so when I tried it in batch, it worked really poorly. I got really low yields, and it was very frustrating because the reaction was working, just not very well. As soon as I switched to low temperature flow, instantly the yields jumped up so much higher and I was able to achieve really high yields that I was really pleased with. So for me, when my research started working was when I started using the PhotoSyn. I think something that's really important with both my research and all research is keeping up to date with all the technology that's coming out. There are things possible in research now that were not possible 10 years ago, 20 years ago, or even 5 years ago. So keeping on top of the latest equipment and techniques, I think is absolutely vital in making sure that your research is cutting edge. It's a really exciting area to be involved in. There is just so much possibility and so much potential that we haven't even explored yet. It's a really interesting and unique area of research, and I'd really recommend getting involved in it. I've had a really good time here in the Cresswell Group at the University of Bath. The group and Alex, they're just so friendly and welcoming, and it's a really collaborative environment. So we're all willing to help each other solve all the problems within our research. We're always sharing what we're up to and what our latest results are. It's a really fun, collaborative environment. So I like the PhotoSyn for many reasons. Part of it is the power of the lamp. The lamp is so powerful and so strong, and that's really a plus side for this particular bit of kit. That's one of the reasons why I really like it. Another thing is the coil size you can have. I think the biggest coil we have is 20 mil, and I've done scale-ups up to about 10 grams, and it's really easy, really simple, really straightforward, and it's a dream to use, really. It's really straightforward.